So today we're going to find out the unit rates. So what we're going to do is we're going to start with example A because we started doing unit rates yesterday. We did cover example A, but we're going to do example A. We'll take a look at example B, and then we're going to move on to the guided practice part and do a few unit rates. Okay, so it says during exercise, Sonia's heartbeat beats 675 times in 5 minutes. How many times does it beat per minute? Now, if you look, what they did is they took the number of beats, which was 675, and they put it over 5 minutes. That's what, when it comes to unit rates, you usually put something over time. Or if it deals with food, it deals with, I think it's money over ounces. We're going to get to that in the next page. So they took the 675 beats and they put it over 5 minutes. What they wanted to know is how many beats it was in 1 minute. So they took the 675 over 5 and they divided the top and the bottom by 5 because you want to make the bottom number equal to 1. To make the bottom number equal to 1, you divide it by itself. And if you do it to the bottom, you have to do it to the top. So they took the 675 and they divided it by 5. When they came up with the answer, you found out that it comes out 135 beats in a minute. That makes sense. Question. What do you write right now? You don't have to write anything. Because I'm just showing you what they did. In a minute, we're going to go flip to the third page, which will give us some examples that we're going to work through. The second part is, asking questions during this is good. It says, to make 4 large pizza pockets, Paul needs 14 cups of broccoli. What they want to know is how much broccoli does he need to make 1 large pizza pocket? Because if Paul's making 4, he's probably making it for his family. But if Paul only wants to make 1 pizza pocket, he's got to know how much he needs for just 1. So they put the 14 cups of broccoli over top of 4 pizza pockets. From there, they wanted the bottom number to be 1, so they divided the top and the bottom by 4. Once they calculated that, it came out to 3.5 cups of broccoli over 1 pizza pocket. So he needs 3.5 cups of broccoli to make his 1 pizza pocket. Hopefully this is making sense so far. Now what we're going to do is we are going to go to the guided practice. That is on the 3rd page of the packet because it's broken into 3 things: finding unit rates, finding average speed, and then consumer math applications. The consumer math applications is pretty cool because it talks about, I do this in the grocery store when something's on sale. You got a smaller one that's on sale and a bigger one. Sometimes you find out it's actually cheaper per ounce to buy the bigger one than the smaller one on sale. And with as many kids as I have in my family, I usually get the bigger one. Okay, so we're going to take a look at number 1, and we're going to work through this one together. Well, actually, I'm going to work you through this one, and we will work on the second one together. So I'm going to do an I do, and then we're going to do a we do, and then we're going to do a you do. So the first one says, a faucet leaks 668 milliliters of water in 8 minutes. So I've got 2 numbers I know. I have 668 milliliters of water, and I know that it drips out that much in 8 minutes. So the number I'm going to put on top is the bigger number. I'm going to put 668 milliliters of water, and I know it leaks that much in 8 minutes. What I want to know is how much water does it leak in only 1 minute. So I'm going to set this up as a division problem because that's what this lovely sign here in the middle means. Okay, so now I'm going to do my division. And there's 2 ways you can do this. We can use the Brinson method, where you get the fraction sideways, and you know that you go 668 divided by 8. Or you could simply go divide by 8. You can do it either way. This way, however, shows you the long division method. So I'm going to do it long division method because lots of you need to remember how to do long division plus the subtraction that goes with it. Last two. Am I going that fast? Okay, well, put the 668 over top of 8. Right, and from there, you have to divide the top and the bottom by 8 because you want to make the bottom number 1. You're fine. So what I'm going to do is I'm going to take these 668 and divide it by 8. Notice the 668's in the box. Will 8 go into 6? No. Will 8 go into 66? Yes. And I know that 8 times 8 is 64. Question. Mm-hmm. 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 Well, if you can add a decimal point and add zeros if the number inside is smaller than the number on the outside. But you're not going to have to worry about that with the stuff we're doing right now. But what I always look at is I look at this number and C is the soonest place I can divide into. And I know that 6 is smaller than 8, so I can't. So I now go over to my second 6 and I go, okay, I can do this one. And I know that 8 times 8, 8 times 8 is 64. I multiply, I put my 8 up top, I multiply those two numbers together and put the answer below the 66. I then subtract 64 from 66. And if I take 4 from 6, I get 2. And 6 from 6 is 0. My next step, so I'm going to bring my 8 down, and I now have 28. Anybody have any idea how many times 8 was in 28 without going over? Yes, sir. 3. Very good. What is 8 times 3? No. 24. 24. Now I'm going to subtract, and I'm going to have 4 left over. Now, when we do this math, we're not looking for remainder. So, can you see okay? Okay. So, now I need to keep going with my division. I'm going to add a decimal point and a 0. And since I added a decimal point here, I'm going to put a decimal point up behind my 3 up top. I bring my 0 down, and I now have 40. Nice thing is I know I'm going to end here. How many times is 8 going to 40? Yeah. Correct. So 8 times 5 is 40. It leaves me with 0 when I subtract. And I now know that there are 800, or excuse me, 80, it's leaking 83.5 milliliters. And I'm just going to do this over that in a minute. Because that made it become 1. Now, the way I like to write this, because I don't like to make it look like a fraction with a 1 underneath, 83.5 over 1. But this is how I like to write it because for me it just is a more familiar way to write it. 83.5 milliliters per minute. Because I already know that there's a 1 right there. Now I'm going to pause it. If you look at the top of the screen, you'll see the next question. It says a recipe for 6 muffins calls for 360 grams of oat flakes. How many grams of oat flakes are needed for each muffin? Now, this is going to put it in grams. In the United States, it's generally going to tell you cups. It's not going to tell you grams. Okay? Because we don't use the metric system unless you're in science, which is really kind of sad because it's much easier to do base 10, which is what the metric system is all based on tens. Our system of measurement is okay. We're stubborn. No, we're not stupid. We're just stubborn. We have our system. We're sticking with it. Okay, let's move on because we're not getting into the debate about that stuff now. So you have 6 muffins calls for 360 grams. Which number am I going to put on top? Very good. Thank you for blurting it out. How did you guess? Why did you guess 360? What's that? Measuring units on top. Okay. Anything else you want to add? Might be, but not always. The other reason is no, because it's a unit rate, and they tell you that they want to know how much for one muffin. So the number you want to reduce to 1 is the number you want on the bottom. Because it says it's 360 grams, and I'll put the G in there because that's what it is. 360 grams in 6, and we'll just call that M for muffin. Okay? Wait, why do you say 1? Because what they've given me is the information. 360 grams for 6. They asked me at the end of the question, how many grams of oat flakes are needed for each muffin? Meaning 1. So they want me to reduce it to 1. I know how many I have in 6. They want me to know how many I have in 1. I can write this one of 2 ways. I can either write it like this, divided by 6, and divided by 6, or I can turn it into a division problem, which is how I prefer to do it. And I use the Brunson method. I tip my fraction sideways. The 360 goes first, falls over first. The 6 is second. Now, yes, ma'am. Oh, I'm going to do this one, and then I'm going to take. We're going to go on to. I decided I'm going to do 2, and then I'll have you guys do a review. So, but actually, I'm going to ask. So yes, I will ask you. How many times is 6 going to 36? Because we know it won't go into 3. 6 times. And 6 times 6 is what? 36. And then I subtract. I've got nothing left, but I still have a place. I have to take care of that place. So I got to bring that 0 down. And how many times does 6 go into 0? I think you probably know the answer to that. How many times does 6 go into 0? It does. How many times? 0. Correct. 6 times 0 is 0. There's nothing left. This way I have filled all my spots because that 6 takes care of the 36 and the 0 takes care of the 0. So I have 60 grams in every one muffin. Or I can write 60 grams per muffin. 60. Okay, we're not here to talk about whether or not you like muffins. We're here to talk about math. All right, so this last one we're going to do, we're going to do a we do on the third one. Okay, let me see if that's checking. Oh, this is finding average. Okay, so if we're going to go try to find average speed, let's from that one. So let's do two. We're going to try an independent one. We're going to do this. We're going to make this independent practice a we do. Okay, so we're going to do this 5 as a we do. That was number 2 example. This is for example 1, number 2. Example 1, number 2. So now we're going to go on to 1, number 5. Question? No, it's that many grams in one muffin. They ask how many grams per muffin. Thank you for asking. No, you're not. Wake up. Okay. So, number 5 says what? Justin, would you read number 5 for me, please? Okay. So, what number's going to go on top? What number's going to go on bottom? Carson, what number goes on top? Right. Why? and we want to find out in 1 hour. So we put the number we want to reduce to 1 on the bottom. Awesome. Well done. Well said. So we have $116.25 over 15 hours. So now what we want to do is find out what they're going to pay it in 1 hour. So once again, two ways of doing this. You can either put the division by 15 on the top and bottom like that, or you can take the 116.25, put it inside your division symbol, and put the 15 on the outside. So now we say 116.25 divided by 15. The question becomes, how many times does 15 go into 116? You may use a calculator. Anybody got one so you can find out quickly how quick it goes in? Somebody punch it in and give me an answer. You can put the whole thing in there. It's good. I'll show you the word from there. What did you get? No, it's not 0. 7? Did it go only 7 times? Did you punch in just 116? I don't think it's going to go in 775 times. It's only going into 116 and 25 cents. 8 times. For the 116. Okay, put 116.25. Thank you. That's the same thing Ben got. 7.75, and I'll show you why. 7 times 5 is 35. Carry the 3. 7 times 1 is 7 plus 3 is 10. That puts me at 105. If I subtract 105 from 116, 5 from 6 is 1, 1 from 0 from 1 is 1, and 1 from 1 is nothing. So I'm left with 11. That number is smaller than 15, so I did it right. Now I bring down my 2. Now I know that 15 goes in 7 times again because it's only 105. So then I subtract again. I can't take 5 from 2, so I have to borrow from that one. So I get 0, and that makes that a stop. 12 take away 5 is 7. I then bring down my 7, or my 5, excuse me. That makes it 75. And 15 times 5 is 75. Oops, subtraction. And I get 0 left over. So what you wind up with is $7.75 per hour. That is 105. That's 112. Can't see it well enough? I could zoom in. Would you like me to zoom in? Okay. Got it. So that's now $7.75 in an hour. So they're actually paying you minimum wage, which is good because that's what you're supposed to be paid if you're working. Unless you're a waitress or a waiter, and then you make lower than that, but you get tips. So you better be good at your job or you're going to make a little bit of money. Then you're a fool to work for them. Okay. So that was a we do. We want to do one more we do? Nah? Okay. Then I'm going to set you on to a you do. And I want you to do number 6. And I'm going to pause it here so you can do it. Okay, the second thing we're going to do is finding average speed. Finding average speed is pretty much the same thing as what we're just doing, but it deals with miles and hours. So it's really not that difficult because they're going to give you like a total miles you went or need to go, and then you can figure out from there how fast your average speed needs to be. So for example, 2, it says the Lawsons want to drive 288 miles to Rainbow Falls in 6 hours. What should their average speed be in miles per hour? Now, mind you, this is done without calculating stops or anything else. So if somebody has to go potty halfway through the drive, you're going to have to go faster to get to your average speed. So what they do is they take the 288 miles they got to go, and they say it usually takes them 6 hours to get there. So if I want to find out how many miles or how many miles an hour that I have to go, I'm going to take this and divide the top and the bottom by 6, with the bottom number 6. So I do once again, I take my 288 and I put it inside my division symbol and I divide by 6. 6 goes into 28 how many times? Oh, 4. 6 times 4 is 24. And then I'm going to subtract. I could take 4 from 8, which leaves me with 4, and 2 from 2 is 0. I then bring down my 8. 6 goes into 48 how many times, Carson? 8. 6 times 8 is 48. Nothing left over. So I need to go 48 miles in an hour. So I need to go on average 48 miles an hour. As you know, that's not a constant, which means at some point you're going to speed up, at some point you're going to slow down. But if it averages to 48 miles per hour, you'll be there in 6 hours. If you go faster, it takes less time to get there. If you go slower, it takes more time to get there. If you average 48 miles an hour, you get there in 6 hours. Now, the other thing you need to remember is when you get done doing this, you need to make sure right here you put in what's called the labels. You want to make sure if you're finding miles per hour, you put miles per hour. If it's like the other stuff, if you notice, I labeled all of them. This was milliliters in a minute. This one was grams in one muffin. And this one was 18 minutes per pound of cooking time. Yes. And it is, thank you for reminding me, it's easiest for me to find your answers if you circle them. And that will also help you to remember if you circle, you go, oh, there's no letters there, I didn't label it. Because on a test, I'll take off a half a point if it's not labeled. So I would circle my answer. Am I going to grade you down if you don't circle your answer? No. That's okay.